Hey folks, this is hopefully the fourth and final video for this particular section dealing with inverses. So if you go all the way down to example 5, I'll do example 5 and 6 in this video. All right, example 5, evaluate without a calculator. And I've given a little hint here. The inside will tell you how to draw your picture. The outside tells you what to do with your picture. So let's just jump right on in, and you'll notice my little how-to box over there tells me to draw a picture using the inside and then to evaluate the outside by using our picture. All right, so first of all, let's draw a picture. Now be thinking about the fact that because it's sine inverse, you know that this is the same thing as the sine of some angle that is equal to 2/3. So this is taking it and writing it normally like I did in the last two videos. Now let's use that concept, use SOHCAHTOA to draw a picture. We know that sine is positive in first and second quadrant, but because of my sine inverse restrictions, remember that's only on the right side of the circle. So that means that of quadrants 1 and 2, I'm going to choose quadrant 1. Find your missing side. So I've already done the Pythagorean theorem there. Found my missing side. So now that I have a picture, I want to take the cosine of the angle that is represented in my picture. So I like to just say I'm taking the cosine of my picture. I'm really not. I'm taking the cosine of the angle in the picture. But you get what I'm saying. And so cosine is adjacent over hypotenuse. So that's going to be the square root of 5/3. If I run over to part B here, again, just taking this, the inside tells me how to draw a picture. And so I know that if I draw this picture, if I think of this as cotangent of some angle is equal to -15/8, that's going to be adjacent over opposite. And so that's where I got my -15/8. The fact that cotangent inverse is negative tells me it has to be either the second or the fourth quadrant, but cotangent inverse has to be the top half of the circle. So I'm not working in the fourth quadrant, I'm only working in the second quadrant. So now that I have my picture, I want to take the secant of the angle represented in my picture. And so that is going to be -17/15. All right, now let's head down to example number 6, where we're going to be working with some of our previous identities that we've worked with in other sections. So you'll notice in in part A, the example part A, I'm taking the sine of an angle minus an angle. Just remember, inverses find angles. So the fact that this is an inverse says, hey, this is an angle minus this is an angle. And I decided to name this guy angle A, and I decided to name this guy angle B. So the very first thing I'm going to do is I'm going to draw a picture for angle A, and I'm going to draw a picture for angle B. So let's take a look at what that's going to look like. So angle A, arctangent, tangent of some theta equals 4/3 is going to be opposite over adjacent. You say, well, how did you know it's in the first quadrant and not in the third quadrant? Because tangent is positive in first and third. Because of my restrictions, right side of the circle. All right, and then when we go draw a picture for angle B, also in first quadrant because cosine inverse is top half of the circle. I found my missing sides there. And so what I did next then was I just simply wrote my difference identity for sine. Remember back in section, oh goodness, I think it was section 7.2, the sine of an angle minus an angle is going to be sine cos minus sine cos. So I just wrote down my identity. There was no work involved in that. And so now I'm going to go to my picture. I'm going to find out what is the sine of my angle A, what's the cosine of my angle B, and I'm just going to plug and chug. So sine of angle A is 4/5, cosine of angle B is 12/13. You can pause the video and make sure that I plugged in everything correctly there. So now I want to do the math on that. And so order of op says that we're going to multiply first. And I do notice that there is a common denominator. And so I will subtract then my numerators, and I will get 33 over 65. All right, let's take a look at part B. Same concept, only instead of it being sine of angle minus angle, this guy is going to be the sine of a double angle. So I'm using my double angle identities here instead of my difference identities, difference of two angles. All right, so the first thing is that I want to simply draw a picture. And by that, I'm not even worried about the 2 at the moment. I'm just taking arc cotangent of -5, and I am changing that in my mind. I'm changing it mentally into cotangent of some theta equals -5, using SOHCAHTOA to draw a picture, and I'm finding my missing side. And if you can't read that, that's the square root of 26, it looks like. All right, so now let's plug in our double angle formula. Our double angle formula is 2 times the sine of my angle times the cosine of my angle. And so now I'm going to use my picture to plug, and then I'm just going to chug and multiply my 3 fractions together, and I'll get -10 over 26, which reduces then to -5 over 13. Now, I was asked this reflection question, and it says, is the cosine inverse of cosine of 7 pi over 4, is that equal to 7 pi over 4? Is this a true statement? Why or why not? All right, so let's take this maybe a little long way around. So think of it like this. What is the cosine of 7 pi over 4? Well, 7 pi over 4 is right here. Its cosine is √2 over 2. All right, so this then is the same thing as the cosine inverse of √2 over 2, because this guy is √2 over 2. All right, what is the cosine inverse of √2 over 2? Well, that's like asking where, and I don't think I wrote this down. I think I just wrote the answer. So this is the same thing as saying cosine of what angle is equal to √2 over 2. Well, that's going to occur on only the top half of the circle, because this is a cosine inverse, and that's what the restrictions are for cosine inverse. So I can't use my 7 pi over 4. I have to use the pi over 4 position. And I created just an extra example here. So if you'd like to pause the video so that you can write it down, that would be fine, or just follow along. And this is the same concept, only with a sine example. So first thing is, what is the sine of 11 pi over 6? Well, the sine of 11 pi over 6 is -1/2. So then what is sine inverse of -1/2? Well, is it 11 pi over 6? And we find that no, it is not. So when you think about this, where does sine equal -1/2? Well, yeah, it does equal it at 11 pi over 6 or at 7 pi over 6. However, remember, on that right side of the circle, I can't use values like 11 pi over 6. I have to use the negative value here. So we're going to use -pi over 6. All right, that wraps up section 7.5.